Hey Legos, thank you so much for having me here at DevFest. I'm really honored to be here and to be talking about documentation. My name is Roina MacNamara. You certainly don't need to see another picture of me, but I'm pretty sure that everybody needs to see a picture of my puppy, so there she is. So I'm Irish. I am based in New York. I've worked for Google for over 13 years in documentation roles, and I'm currently a technical writing manager in Google Cloud. So, why is a technical writer here talking to engineers in Lagos about documentation as if it was something engineers should be doing? Well, documentation is core engineering work. It isn't toil, it isn't an afterthought, and it isn't a nice to have. It's critical to adoption, developer velocity, code quality, and the reliability of services running in production. I say that documentation is as fundamental to the discipline of software engineering as testing. So, why is it just not very good? And it's not just me saying that. It seems that nobody is happy with documentation, and rightly so. Over the years, we saw this over and over again internally, where internal documentation was identified as the biggest productivity challenge to engineers at Google. And we see it externally too, and I hear it from other companies. It's fundamentally a problem. Sometimes the information you need just doesn't exist at all. Sometimes there is documentation, but it's often not very useful, and you can't even find the information you need out of a pile of dross. And sometimes, even if you can find the information you need, it's incorrect, stale, or dangerously out of date. Sometimes it seems that documentation is everybody's problem, but it's nobody's job. At Google, for example, we do have technical writers, but we have very few of them, and they are almost all focused on working on external documentation. The reality is that most engineering teams at Google need to document their own code. And what you see here is often a case of conflicting priorities. Everybody wears two hats when it comes to documentation. So, as a consumer of documentation, when you're coding and researching and you need information, documentation is a super high priority. You want that information now. So then you get what you need and you go back to your IDE and you code, code, code. And all of a sudden, documenting that code you're writing is often the lowest priority and the first thing to go, even though the next person who uses your code is going to need that documentation. But you know what? I actually don't blame you a bit because as engineers, your job and what you are paid for is to design and write and ship code. And as long as documentation is perceived as drudge work or as toil that doesn't get recognized or rewarded at promo and perf time, that isn't scheduled for, that isn't budgeted for engineers to drop it on the floor is completely rational behavior. But it's harmful because people need to use your code. And without documentation, they're going to find it very difficult to do so. And the reality is, as well, documentation costs. It requires resources to create and maintain. If engineers are to do docs right, that work needs to come out of the time that they have budgeted for development. This is a reality that we have to face. Doing docs better requires managers and leads to rigorously identify documentation requirements, establish baseline standards for quality, and ensure that this work is budgeted for in the project schedule and recognized during project performance review and promotion time. But that's not the norm just yet. Documentation is not yet integrated into engineering culture, and as a result, we all feel the pain. But there's an example that we can look to for inspiration, and that example is the world of software testing. Because 10 years ago, software testing was done ad hoc or not at all. And this came at a great cost to velocity, to quality, and to reliability. Today, however, after a lot of painful growth and incidents, software testing now has evolved into a highly professionalized discipline, and it's fully integrated into engineering workflow and the discipline of software engineering. The documentation world can learn much from this example. But say we believe in this and we want to affect this change. The truth is that most of us don't have the authority to mandate change in our organizations, to say we shall now care about documentation. But if we believe in the power of documentation and we want to change engineering culture, we need to be able to influence without authority. We need to be able to demonstrate the value of good docs. But before that we do that, we actually need to be able to describe what good docs actually are. You know, what actually do we mean when we talk about documentation quality? So in this section, I'd like to propose a framework that is borrowed directly from the field of software testing, where it's used to describe various aspects of software quality. Essentially, there's two aspects of documentation quality. There is structural quality and functional quality. And each of these contribute to the overall quality of a document. The first one we want to look at is structural quality. Essentially, structural quality describes what the documentation should look like. It's the kind of quality that writers are referencing when we refer to ourselves as wordsmiths. I'm thinking about things like grammar, style, punctuation, tone of voice, organization, and architecture. Structural quality is pretty easy to detect and determine. Spelling is correct or it isn't. Style is followed or it isn't. Links are broken or they're not. I mean, that's an advantage, but it's also a problem because structural quality tells us nothing at all about the effectiveness of that documentation. But because it's so easy to detect and measure, it's tempting to overdo it, to focus on structural quality at the expense of other aspects of documentation quality. And here I'm mostly talking about functional quality, which is a less familiar term, but actually a really simple idea. A documentation with high functional quality is quite simply a document that does what it is supposed to do. It satisfies its stated requirements, usually some kind of business goal. For example, the goal of a document can be to grow adoption, or to deflect support calls, or to enable an SRE to troubleshoot and resolve an outage, or to get a developer up and running to reduce the time to hello world. It is for something. It has a purpose. And it's incredibly important that we are clear about this. So for example, you could have a document that has high structural quality, it's beautifully written and organized, but it has low functional quality. Overall, your documentation is poor. But you can have a document that has okay structural quality and high functional quality. Your docs are good overall. They're helping people to achieve their goals. I am not saying that structural quality doesn't matter, but I am saying that it is by and large a means to an end. And if we want to think about what our documentation is for, if we want to deliver business value, to make our teams more efficient and effective, functional quality must be our goal. Structural quality is a means to that end, but functional quality must always come first. So how do we make that happen? Well, the first thing is that when we are thinking about documentation, we are crystal clear about thinking about our functional requirements. Every document we write must have a reason to exist. What is this document for? Why am I taking time away from coding to write it? So the first thing we need to do is to establish functional requirements. There's a lot of different types of engineering documentation, reference guides, tutorials, overviews. I'm going to take one highly functional example of a playbook, for example. And let's look, what are the functional requirements of this type of documentation that's intended to help an engineer troubleshoot an outage? Well, we know it needs to be complete. It needs to cover all alerts. It needs to be accurate. When everything hits the fan, you need to be able to work through it. It needs to be discoverable. People need to be able to find it, so it needs to be in a predictable location. It needs to have guidance and escalation. These are the kind of things we need to think about. Every document has a purpose. I can't emphasize that enough. Before you put your precious time into writing a doc, consider carefully, why am I doing this? What is this document for? And once you have established those requirements, well, then execute on them. Write the docs. And there's a lot of guidance out there about writing documentation, about getting started, about doing um, good docs and creating functional engineering sets. It's a bit outside the scope of this talk, but I do want to talk about the tools and the processes that you use to actually create this documentation. Because one of the things we have found is that doing docs better requires changes to both tooling and culture. I've been a technical writer for way more than 2 decades, and I've worked on this challenge a lot. How do we get engineers to create and maintain docs? Over the decades, I've been involved in all sorts of efforts to address this, and all but one pretty much failed. And what I learned from this was doing docs better does require us to change both engineering tooling and culture, our approach and our mindset about docs. Neither alone is enough, but both of them have the same goal. We must reduce every possible barrier to creating and maintaining documentation. We must remember that engineers, by and large, don't want to be doing it, but they need it and they should do it. We must make it easy. Our experience is that while each of these is necessary, tooling must come first. So, for example, if we go back 5 or so years at Google, um, we were in a situation where documentation had consistently been identified as the biggest barrier to engineering productivity. So when we looked at it and we looked at how engineering documentation was done, we saw that all our code lived in what's called Google 3, which is probably the world's biggest code base. It was all in one place where it was consistent and tested and predictable. But our docs could live anywhere at all. There are literally tens and tens of thousands of wiki pages and Google sites, 90 something percent of which had never been visited or updated in months and months and months. Info could live in email and docs and a post-it note. And we wanted to see why that was and what were the barriers. So we took the time to talk to a lot of engineers, and all of them had basically the same complaint about documentation. The docs don't exist, or if they do exist, you can't find them. And if you can find them, you can't trust them because they're almost certainly out of date and stale. And we said, why is that? And what we heard from every engineer was they felt bad about not doing docs. We didn't meet a single engineer who said docs don't matter. They knew docs were important. They knew they should write them, but it was hard. They had to switch to different tools, lose context switch, and they didn't have the time or the incentive to do that. And we became really convinced that documentation will never be part of engineering culture until it is fully integrated into the code base and to the workflow. It is just a seamless, thoughtful, natural part of that workflow. So the solution that we built was actually super, super simple. Docs live in Markdown, right in source control next to the code it describes. And we have a service that renders it beautifully at a predictable URL. It takes care of all the look and feel. It's in a portable, simple format like Markdown. And the principles behind this and why this system was successful, it is now used by over 50,000 projects at Google, is the first one was they don't want to write docs. They have to write docs. They don't want to write docs. Let's meet them where they are. Keep documentation in source next to its associated code. This lets engineers create and maintain docs using the exact same tools and workflow they use to create and edit code. So their IDE, their issue tracker, their code review tool. Because this is simple, because it reduces context switching, because you can make a change in the code and in that same change, go up in your file tree, update the doc and have the file, the code and the docs reviewed together, Engineers are far more likely to maintain the docs they do create. About 30% of all code changes in our repo now actually also contain updates to documentation. So, our experience tells us that the best solution is for docs to live alongside code. But we know that's not always possible. So if this G3 doc system doesn't work for your project, what we strongly recommend, the most critical step, is choose one canonical repository for your documents. Don't split them across repositories. There's advantages to this as well because a more predictable location for docs makes those docs more discoverable by humans and systems. And it also enables other things that we didn't expect, new features and functionality that remove much of the toil from creating and maintaining documentation. For example, we created a Markdown linter and formatter that ended up being integrated into our IDEs that really removed the need to manually tinker with Markdown and fixed a lot of common problems. Interestingly, there's a lot of data that is interesting that is buried in configuration files. We found a way to surface that information directly in our documentation, which removes the need for people to manually document things like ownership and then risk the content forking and the ability to detect broken links. Most importantly, we had the ability to include live code in our documentation. So instead of relying on copying and pasting static code blocks that are just destined to decay as the underlying code changes. Another principle is automate everything you can because we are all human, and that means that we are lazy and we are error prone. If you can automate anything, do it. An example is what we call G3doc EngPlay, a variant of G3doc that's integrated with our monitoring and alerting tools. So for example, every alert will automatically have a documentation page generated for it. And we'll have a tool that compares alerts to the playbook entries and throws warnings if an alert is documented. Interesting, we can have support for variables, so we can actually update documentation on the fly with information from monitoring, such as the ID of the job that created the alert or the affected cluster. So these are things that come up. So apart from tooling, there's also some cultural changes that are really, really critical. And what we found was absolutely important was we need to remove the cultural barriers to doing documentation well. And one of those is the idea of perfection. A core principle of Google in our SRE is that we strive to make our systems reliable enough to keep our users happy, but no more. We don't strive for our system for 100% uptime. Increasing reliability comes at a cost. You can maximize stability, but that limits how fast you can deliver new features to our users. And similarly, if we require high standards of writing, that's counterproductive because it can intimidate engineers and prevent them from creating docs. Similarly, polishing documents past the point where the key information, is it there? Is it up to date? Is it discoverable? Is it clearly conveyed? Going past that for internal documentation, it's a waste of time. You could better spend that time improving other parts of the documentation or even just your code itself. Documentation is an iterative process, just like code. Another area that we need to learn to embrace what the American writer Anne Lamott describes as the shitty first draft. Because an imperfect document, it's infinitely more useful than the perfect one that doesn't exist. Ask yourself, does the doc meet its functional requirements? Is the required information there? Can I understand it? If yes, great, move on to the next thing. You know somebody else will improve the documentation later. But better trumps best. Set realistic standards for quality. If you're an engineer who wants to instill a culture of docs on your team, remember that you have power. Most people have a code review or a peer review system, you can withhold approving on code until the docs are there. Do it. Docs or it didn't happen. If somebody submits a change to you and there isn't documentation associated with it, ask for it. You might get pushback on this, but I will push back on that because it is not as onerous as the requirement sounds. Not all changes require updates. Here's a good rule of thumb. If somebody needs to change their behavior after this change, then the code change and the change list should include an update to the documentation. On the other hand, if the change is small, like a refactor or a tweak, and it doesn't require tests, it probably doesn't require documentation either. Use your judgment. Simplify and automate as much as possible. But if your team balks at this requirement, remind them that simple project documentation like this, it's about saving the information in your head, putting it on paper so others can access it later without bothering you. And doc updates usually aren't that onerous. Generally, it'll scale with the size of your code change. If you're writing thousands of lines of code, you might need to write a few hundreds of lines of documentation. If it's a one-line change, you may just have to change a word or two. But expect it. It should be a natural, normal. If it's not docked, it is not done. And finally, another cultural thing is to remember that every line of documentation, just like every line of code, should serve a purpose. And when it no longer does, it should be archived or deleted. Can't emphasize this enough. Unnecessary or unhelpful documentation is a tax. It is technical debt. It adds complexity and uncertainty, and it often obscures or even contradicts useful information. That's the best case scenario for stale documentation. The worst case is catastrophe. Delete them. You're using source control, right? You can always get them back if you need to. You almost certainly won't need to. And finally, have a culture in your team where you recognize and reward docs because it is core engineering work. Call people out for it, acknowledge it, thank them, peer bonus them. Make sure that people know that this work is valued. And it should be valued everywhere in the organization. And because leadership support is so important to driving change, in the next section, I want to focus on how best to communicate the value and impact of documentation work in your organization. If we want to convince leadership to invest time and resources in documentation, it is critical that we gather data that demonstrates the quality, effectiveness, and business value of your documentation. And to do that, we need to focus on functional quality. We saw before that structural quality, it's easy to measure. Functional quality is far more compelling and it's far more persuasive, but its data has a different shape and it can be trickier to gather. Typically, it falls into three buckets. The first is measurable success. Here's an example. Support calls about a particular issue were reduced when you wrote a doc about it. User behavior. Users were able to successfully follow procedure and complete a task. And the third is sentiment data. This is your users telling you via surveys, bugs or issue tracking, feedback mechanism, or just talking directly to your team. But this is users telling you this documentation worked for me. This was good. This kind of data is trickier and it's sometimes prone to misunderstanding and can be too easily dismissed, though it's not statistically significant. You know, sentiment data is real data and it can sometimes be the only data that you can get. Remember that when a user tells you they like their doc, they're explicitly telling you that the doc met the requirements. You can gather sentiment data via surveys, bug and issue tracking, feedback mechanisms, or talking to the teams you support, but it is worth doing. And then you can use this data to paint a compelling picture. Now, you could use structural quality to report on your documentation, but it's not very compelling. Your doc is beautifully spelled. It's got no grammar errors. So what? Nobody cares. This is not going to get anyone to invest in your program. To build a convincing story that conveys the value of your documentation work, you need to focus on functional quality, which is far more compelling and allows you to demonstrate business value. So here's an example. You could say that I created a proposal. I worked with the engineers to revamp the playbook. I did this as a result. The playbook received 5 times more visits. There was a decrease in the time it takes a new engineer to go on call, and we got positive feedback from all our users. That's compelling. That is convincing. When you have gathered that data, I encourage you to share it in your organization. Share it everywhere. Share it with your teammates, with other engineers, but also with technical writers who might be interested in learning from your experiences and adopting your processes. Share it with managers because they want to be able to understand why we're spending our time in documentation. For sure, share it at performance review and promotion time, because if you use good functional quality data, you are demonstrating your impact. And this is going to help you build a case for recognition for the good and noble work that you have been doing in documentation. And share it with the other teams we work with and collaborate with. I want to do a call to action. I want us to do docs better as an industry because this is core engineering work. Let's do it. How do we do it? Well, let's focus on functional requirements and quality. That's number one. Number two is do everything you can to reduce the cultural and tooling barriers that prevent engineers from creating and maintaining documentation. Where every piece of friction you can remove from the process increases the likelihood that engineers will contribute to documentation. Gather data that demonstrates the business value of your docs. People talk about page views and traffic, which is interesting, but it's not definitive. It says nothing about the value that those docs bring. Focus on the functional requirements and how those requirements have been met, the demonstrated impact on your business. And when you have that data, use it, share it, and use it, to advocate for documentation in your organization. Use it to build a compelling case. The documentation work is core engineering work. It's worthy of support, funding, recognition, and reward. Because it is. Thank you so much for having me. I look forward to seeing you in the chat. And you can hit me up, Roina M, at Twitter. I'm easy to find on LinkedIn or on other medias. Thank you so much for having me. Thank you. Good night.